Namaskar, I welcome all of you to my YouTube channel. This is lecture number 30 on complex analysis and it is the continuation of the last video. Students, in my last video, I had explained total two methods. That means method number 1 and method number 2 for finding residue at poles. In this video, I will be explaining the remaining two methods. That means method number 3 and method number 4 with examples. So, without wasting time, let's get started. According to method number 3, if z equal to a is a pole of order n, then residue at z equal to a is given by 1 by n minus 1 factorial into d to the power n minus 1 divided by dz to the power n minus 1 of z minus a whole to the power n into f of z at z equal to a. Next, method number 4. According to this method, residue of complex function f of z at z equal to infinity is given by limit z tends to infinity minus z into f of z. Now, let me solve some numerical problems to understand method number 3 and method number 4 properly. Problem number 1. According to this problem, we have to find out the residue at the pole z equal to 0 of the function f of z is equal to 1 by z square. Students, here we have seen that z equal to 0 is a pole of order 2. So, definitely we have to use method number 3 for finding residue of the function f of z at z equal to 0. So, here the value of n is 2 and value of a is 0. Okay? Now, let me write these points. Given f of z is equal to 1 by z square. Here z equal to 0 is a pole of order 2. So, therefore, residue at z equal to 0 is equal to 1 by n minus 1 factorial. N means 2. 2 minus 1 factorial into d to the power n minus 1. 2 minus 1 divided by dz to the power n minus 1, that means 2 minus 1 of z minus a. Here a is 0 whole to the power n, that means square, into f of z. Here f of z equal to 1 by z square. We have to find out the value of this differentiation at z equal to 0. Now, let us simplify this term and this term. We know 2 minus 1 factorial is 1 and 1 by 1 is always 1. So, after simplifying, we will get dz of z minus 0 whole square, value is z square, into 1 by z square at z equal to 0. We know z square into 1 by z square value is 1. So, dz of 1 at z equal to 0. 1 is a constant term. So, dz of 1 is 0. So, finally, we will get residue at z equal to 0 as 0. So, this is the answer. Next, let me solve problem number 2. According to this problem, we have to find out the residue at the pole z equal to 1 of the function f of z is equal to 16z divided by z plus 3 into z minus 1 whole square. Students, here we have seen that z equal to 1 is a pole of order 2. So, definitely we have to use method number 3 for finding residue of the function f of z at z equal to 1. Here the value of n, that means order, is 2 and the value of a is 1. Now, let me write these points. Given f of z is equal to 16z divided by z plus 3 into z minus 1 whole square. Here z equal to 1 is a pole of order 2. So, therefore, residue at z equal to 1 is given by 1 divided by n minus 1 factorial. Here the value of n is 2. 2 minus 1 factorial into d to the power n minus 1, 2 minus 1 divided by dz to the power n minus 1, that means 2 minus 1 of z minus a whole to the power n. Here the value of a is 1. So, z minus 1 whole square, because the value of n is 2, into f of z at z equal to 1. Next, let us substitute the value of f of z here. So, finally, we will get 1 divided by 2 minus 1 factorial. So, this term will be 1. So, we will get dz of z minus 1 whole square into 16z divided by z plus 3 into z minus 1 whole square at z equal to 1. Here z minus 1 whole square and z minus 1 whole square will be cancelled out. So, finally, we will get residue at z equal to 1 as dz of 16z divided by z plus 3 at z equal to 1. Next, let us apply this formula. So, after applying this formula, we will get z plus 3 into dz of 16z. So, its value will be 16 minus 16z into dz of z plus 3. So, its value will be 1 divided by z plus 3 whole square at z equal to 1. Now, let us put z equal to 1 here. So, we will get 1 plus 3, 4. 4 into 16, 64 minus 16 into 1, 16 divided by 1 plus 3 whole square. 4 square means 16. So, after simplifying this term, we will get residue at z equal to 1 as 3. So, this is the answer. Okay? Finally, let me solve problem number 3. According to problem number 3, we have to find out the residue of the function this one at z equal to infinity. Students, for solving this problem, we have to use method number 4. According to method number 4, the residue of a complex function at z equal to infinity is given by limit z tends to infinity minus z into f of z. Now, let me solve this problem. Given f of z is equal to z square divided by z minus 1 into z minus 2 into z minus 3. So, therefore, residue at z equal to infinity is equal to limit z tends to infinity minus z into f of z. Now, let us substitute the value of f of z here. So, finally, we will get limit z tends to infinity minus z into z square divided by z minus 1 into z minus 2 into z minus 3. After simplifying, this term can be written as limit z tends to infinity minus z cube divided by z minus 1 into z minus 2 into z minus 3. So therefore we get residue at z equal to infinity as limit z tends to infinity. This term can be written as minus 1 divided by 1 minus 1 by z into 1 minus 2 by z into 1 minus 3 by z. Next, if we substitute the limit here, then we will get minus 1 divided by 1 into 1 into 1. Finally, we get residue at z equal to infinity as minus 1. So this is the answer. This is all about today's video, and I hope that you have learned a lot from this video. In my next lecture, I will teach you Cauchy's residue theorem.